In today's episode, you will learn how to make an IoT-based door security system using a magnetic reed switch, Node MCU ESP8266 Wi-Fi module, and Blink application. Each time the door is opened or closed, a notification message is sent to the desired application. When the door is closed, the right side LED is turned on, and when the door is opened, the left side LED is turned on. The Node MCU ESP8266 Wi-Fi module programming is done in such a way that it sends only one notification message when the door is opened or the door is closed, which became possible by using a flag in the programming. So in this tutorial, you will also learn how to use a flag in the programming to stop the unnecessary repetition of code. Even if this application is running in the background, still you will be able to receive the notifications. This project can be used for monitoring the lockers, cupboards, and this project can also be used in advanced level projects like monitoring the car bonnet, doors, etc. In fact, this project can be used anywhere where you need the magnetic reed switch. We can also name this project as the IoT reed switch. In this project, we will cover number 1, complete circuit diagram, number 2, interfacing, number 3, Blink application designing, number 4, program explanation, and finally number 5, testing. Without any further delay, let's get started. The components and tools used in this project can be purchased from Amazon. The components purchase links are given in the description. This schematic is designed in Ksoft Eagle 9.1.0 version. If you want to learn how to make a schematic and PCB, then watch my tutorial. The link is given in the description. First of all, let's start with the power supply, which is used to power up the Node MCU module. This power supply is based on the famous LM7805 voltage regulator. J1 is the female power jack, and this is where we connect a 12-volt adapter, battery, or a solar panel. Two 470 microfarad capacitors are connected at the input and output sides of the 7805 voltage regulator. A 330 ohm resistor is connected in series with the 2.5 volt LED. This is a current limiting resistor. The output of the voltage regulator is connected with the VN pin of the Node MCU ESP8266 Wi-Fi module, and the ground of the power supply is connected with the ground of the Node MCU module. A magnetic reed switch is connected in series with a 10K resistor. This is a pull-up resistor. When the two contacts of the reed switch are open, it gives 3 volts to the digital pin D0 of the Node MCU module. On the other hand, when the two contacts of the magnetic reed switch are closed, the ground is given as a signal to the digital pin D0 of the Node MCU module. This is the final Node MCU power supply circuit board after soldering. The PCB designing, online order placement, and soldering is already explained in my previous tutorial. The link is given in the description. For the easy interfacing, I'm going to fix the magnetic reed switch and the 10K resistor on the Vero board. As you can see, a 10K resistor is connected in series with the normally open type magnetic reed switch. This leg of the resistor is connected with the 3 volts, while this leg of the magnetic reed switch is connected with the ground. A wire from the middle of the 10K resistor and magnetic reed switch is connected with the digital pin D0 of the Node MCU module. First of all, open the Blink application. Click on the new project and enter the project name is IoT Door Security. Click on the Choose Device and select Node MCU. Make sure you set the connection type to Wi-Fi. Finally, click on the Create button. An authentication token will be sent on your email ID, which will be then used in the programming. Simply copy and paste it in the programming. Now click anywhere on the screen and search for the LED and add it. Click again on the screen and add another LED. Click again on the screen and this time search for the notification widget and add it. Click on the first LED, set the name as Door Open and select the virtual pin V2. Now click on the second LED, set the name as Door Close and select virtual pin V3. That's it. Our application is ready, and now let's discuss the Node MCU programming. All the libraries used in this project can be downloaded from our website. The link is given in the description. If you're using the Node MCU module for the first time, then I highly recommend first watch my Getting Started tutorials on the Node MCU ESP826655 module, which explains how to install the Node MCU board, how to fix some of the most common errors, and how to download the Blink library. This is the authentication token which was sent via email. I simply copied and pasted over here. This is the name of the Wi-Fi router and this is the password. This is the same function I have been using in almost all of my IoT based projects based on the Node MCU module. The magnetic reed sensor is connected with the digital pin D0 of the Node MCU ESP826655 module. The variable flag, which is of the type integer, is used as the flag. In the white setup function, I activated the serial communication using the serial tone begin function and selected 9600 as the baud rate. The blink.begin function takes 3 arguments as the input: the authorization, SSID and password. Then I set the read sensor as the input. Sensor value 1 is a user-defined function. This function is called every 1 second. Then starts the while loop function. Inside the while loop function, we have only 2 functions, blink.run and timer.run. As I said earlier, sensor value 1 is a user-defined function. This function has no return type and does not take any arguments as the input. This condition checks if the door is closed and the flag is 0. Then turn off the door open LED and turn on the door closed LED and send notification message, and finally change the flag status from 0 to 1. This condition checks if the door is open and the flag status is 1. Then turn on the door open LED and turn off the door closed LED. Send a notification message and finally change the flag status. So that's all about the Node MCU programming. I have already uploaded this program. Let's watch this project in action. Support me on Patreon for more videos. I hope you liked today's episode. Like and share this video with your friends. See you in next episode and thanks for watching.